Hello and welcome to the Innovation in Electricity webinar. It's clear there's a huge energy transition underway. Global milestones, global emission targets require governments to meet aggressive timelines with various intermediate goals and a key milestone at 2050. The UK, for example, has a target of being fully decarbonised by 2035 and net zero by 2050. All this while balancing the energy trilemma, meaning broadly that energy must be clean, secure and affordable. The UK's National Grid electricity system operator regularly publishes its future energy scenarios, in which it outlines several paths for the development of energy system over the next 25 years or so. It's clearly of the opinion that what it calls social change is a key component in decarbonisation. Effectively, this means smart homes, demand-side response, storage, electric vehicles, etc. Just give you a flavour of that, just here are a couple of quotes. This is what they have to say. They say the growth of distributed flexibility, that means flexible energy demand resources such as storage and electric vehicles, heat pumps, thermal storage, connected at distribution level, is a key enabler of net zero. Of transportation flexibility, they say increasing implementation of smart EV charging is a low regret action to help reduce the impact of peak demand and reduce curtailment of renewables. And of locational signals, they say market reform is needed to provide the real-time locational signals required to optimize decisions on when and where flexible energy resources are used. Improving locational signals has a potential to deliver significant cost savings to consumers and support the delivery of decarbonisation targets. So what's happening in the innovation space to help all of this and help us to move forward? I'm Tim Rogers from Energy Wise Training, and today I'll be focusing and discussing exactly that with three company founders. Tia Gordon is co-founder of It's Electric, Konstantin Fedoseev is co-founder of Visionary, and Sebastian Hagland is co-founder of Rebase.Energy. Tia, Konstantin, Sebastian, can I ask you briefly to introduce yourselves and your companies? Tia, if you wouldn't mind, can I come to you first?
Of course. Hi, everyone. So my name is Tia Gordon. I'm the co-founder of It's Electric. We are a Brooklyn-based company, so we're reaching you here from the States on this Friday. And we overcome the largest barriers that cities face in the deployment of electric vehicle charging. It's very different, the conditions we have here in New York versus in London. So excited to dive into this panel with everyone.
Super. Thanks, Tia. And Konstantin.
Yeah, hi everyone. I'm Konstantin, co-founder at Visionary, and I've been working for different companies in the electricity sector for almost 8 years before running Visionary with my co-founder and also CTO, and we make energy storage plus cloud-based solution for distribution grids, grid companies in the US and around the globe. Nice to be here.
Thanks, Konstantin. And Sebastian.
Absolutely. Hello, everyone. So yes, I'm Sebastian Haglund from Rebase.Energy, one of the co-founders. So yeah, my background is really in energy trading. So I saw kind of that part of the energy system becoming more and more volatile and seeing really the need for having the right data at the right time, in the right form, and at the right place in order to take really good decisions that helps to kind of balance and control the system in real time. So yeah, when I was working with this, a lot was done still with intuition, and that was kind of a big hurdle. And being kind of entrepreneurial driven and minded, I actually decided to start Rebase as on the basis of that. So what we want to do is really empower energy data scientists with data and tooling in order to help them to drive better decisions with data.
Fantastic. Thanks, Sebastian. And thanks all. It sounds really interesting. For those watching, if you're watching a live event, please ask questions in the comments section. And if you're watching the recording, feel free to reach out to any of us directly, and we'll do our best to answer you as soon as possible. I think let's dive into some questions, and so we've set up we've set the scene at a global level, but at a more sort of local level or a fine level. As founders of these companies, what do you see as the main drivers in electricity systems today? Tia, perhaps I could come to you first on that one.
Sure. So as a founder, sorry, just to re-articulate your question, the main drivers for...
Yeah, sure. Yeah, just the main drivers in electricity systems. So the changes, where there's an awful lot of change going on. What's driving you and your business to do the things that you do? What do you see changing?
Absolutely. As we all know, we're undergoing a once-in-a-lifetime transition to clean transportation, where we're hopefully eliminating our reliance on fossil fuels and moving to fully electric vehicles. So we need now to understand how to power those vehicles. And so the energy transition that we're seeing here in the United States is really driven by the demand that's projected. So right now in the United States, there's 126,000 public level 2 chargers. Our White House predicts that we need 1 million of these. So we need to 9x this by 2030. So how are we going to get there, given the fact that we have limitations in terms of grid capacity? We have limitations in terms of finance, schedule, all the sort of normal project management terms that come into play when it comes to basically building new infrastructure. So right now, what the country is facing is almost a race against time, a race to help decarbonize, a race to make this transition, and a race to rely upon infrastructure that wasn't built to necessarily accommodate this type of support in terms of vehicle charging. So it's a very interesting time to be in this space, and there's a lot of dynamics that are at play.
So that's fascinating. So just to reiterate that, so you've got 126,000 level 2 chargers at the moment. That's 1 million
public level 2 chargers. Yeah.
By 2030, which is what, six and a bit years?
Let's call it. We're going to call it 6 and change.
Wow. Okay, this is just it's a huge change. Yeah.
Exactly.
And Konstantin, what are you seeing? What are the drivers for what you see?
Actually, that's great you've asked Tia before me, because your company works in particular on the same things as we do, but on the consumer side. I mean, reducing the grid load by installing smart curbside charging stations. And from my point of view, the main drivers in the electricity systems today are the changing curve of energy consumption and the bi-directional energy flows from renewables installed behind the meters. And let me explain, and I want to share my screen. A second. Do you see my screen?
Yeah.
Yeah, great. Yeah, and here is an average power consumption curve by hours 30 years ago, and no one could imagine that consumption would be changing so rapidly. Consumption is growing and everything is becoming electric, and even our cars, as Tia mentioned. And one Tesla's charging station consumes the same amount of energy for an hour as 10 or even 15 houses for a day. And here's curve changing and new peaks. And on the other hand, a huge amount of rooftop PVs are installed every day. And for the local distribution grid, these bi-directional energy flows looks like that. In fact, by selling energy back to the grid, you just waste it out. because of low efficiency for transmitting this energy through the grid from your house to 100 miles away. And yeah, and distribution grids right now are a bottleneck driven by changing consumption and producing energy by consumers. And higher peaks, higher consumption, wider fluctuation of consumption's curve, higher grid losses, and faster wearing out of the grid equipment and many other problems distribution grids face every day. And 2 years ago, we saw a lack of alternative solutions for flattening this curve, helping power grid companies meet new challenges and increase efficiency of local energy production. So that's why we have started Visionary. And so summing it up, changing consumption and producing and selling energy by consumers are the main drivers today for distribution grids, because distribution grids inextricably linked with consumer level and transmission and generation.
Thanks, Konstantin. That's really interesting. So you see that there's a difference on the supply and the demand side at a local level. You're seeing spikes in demand, supplies at a different time period, so that needs to be flattened out locally.
Yeah, right on the local distribution level.
Interesting. Okay, thanks, Konstantin. Sebastian, what are you seeing?
Yeah, I mean, I would actually like widen the perspective a little bit and taking even a couple of steps back. So it started with like climate tech 1.0, if you wish. This hardware kind of companies that build up. You know, I'm from the Nordics, so we have Vestas here from Denmark, which is a wind power company that's now a giant, but back in 1970s they were like building tractors, right? So there's a lot of things that have been happening even before we started as companies, and now with this second, boom of climate tech companies, now it's the technology's there, it's cheap, green and fossil-free electrons are cheaper even than the carbon ones. And now it's about how do we manage all this, because we have a huge amount of these distributed assets, talking hundreds of millions, not billions of them. So how do we handle that? And that is all driven by, consumer behavior and demand, just as Tia and Konstantin mentioned. So the consumers, they expect to have a completely different experience from their energy and much more ownership and control. At the same time, we have the energy crisis and the volatility power prices, which are, of course, also shaping the consumer behavior. So, yeah, and our angle at this, of course, from Rebase side is that we believe that the future has to be digital in order to handle all these complexities and moving parts in order to keep everything basically in track and in balance.
Okay, so that's really interesting. So we've got, you mentioned millions, potentially billions of assets, all generating and consuming. A smart distributed environment. In theory, yeah, sure, they can communicate with each other, but how on earth do you do that? So you're looking at the data and the tools and the systems. Okay.
Exactly, and there's also where I think there's a lot of need for innovation. In just this kind of communication layer and actually being able to be operable and interoperable and communicate with different interfaces and across companies and assets. So we've got this huge a kind of a huge challenge in front of us, and there are some sort of there's the macro level and there's the micro level challenges that we're seeing here. How is that being? How are we addressing those things? And where do you see
as founders, where do you see the leading edge of innovation? Because this is what we need to be able to really tackle some of these problems. Konstantin, if I could come to you, where is the leading edge at the moment?
Yeah, back to the previous question. Firstly, as I said, the main vision of Visionary is to flatten the consumption curve for rated working modes of distribution grids and bring more decentralization into present centralized structure of the grid. And yeah, one more time, I want to share my screen. Here we are. And in a nutshell, Visionary is an energy storage plus cloud-based solution, and our clients spread out small-scale energy storages through the distribution grids and save 5, 7, or even 10 times in capital expenses for grid modernization. And energy storages support the grid during peak load time, collect energy from local sources, and provide additional benefits like voltage support or new services for consumers. And grid modernization isn't required anymore. Here is a few services that energy storages provide. And cloud service, in the second part of our solution, collects 62 parameters data from energy storages, from the grid, from energy consumers side, local generation, and even about local weather, and provides all this data to the utility companies. It helps manage distributed energy sources all around Visionary's energy storages installed into distribution grids. And one of the most important role of the cloud service is aggregating decentralized energy storages into virtual one. And the third level of innovation in Visionary is keeping in focus its design. I mean how people will use it, how it will work in different conditions. And from my experience, numerous innovations failed because those were hard to implement into existing structure of companies, especially in the rather conservative energy sector. And that's why Visionary focused not only on technical innovation, but also on design of hardware and software elements of our solution for seamless integration to the existing power grids and management system in power grid companies.
Fascinating. So these are local distribution storage solutions, right? That as you said at the start, contribute to being able to flatten that demand, the supply and demand curves.
Yeah, absolutely right. Yeah.
That's fascinating. Tia, massive challenges in the States. You got to get 126 to a million charge points. What's happening at the cutting edge? How on earth is that problem being solved?
Sure. So I'm going to share my screen as well, just to throw up some quick visuals.
Cool.
Let's see. May I have screen sharing, please?
Yeah.
So as you mentioned, we need to get up.
Just a second.
Let me know. That's a problem. If not, I can just speak to it without it.
Yeah, try again.
There we go. Let's try that now. Perfect. So as mentioned, again, we need these 1 billion level 2 chargers by 2030. Totally in this country, we need 1.2 million electric vehicle chargers but of that 1.2 million, 1 million are level 2. And so right now in the United States, as I'm sure it is in most other places, the way that electric vehicle chargers are installed by having a direct utility connection. So our main electrical lines in the States are largely below ground. In some areas, they are above ground with their utility poles. But on the Northeast coast and throughout most parts of the US, our utilities are below ground. So in order to access that energy, an electric vehicle charging company would need to basically go about 7 feet below grade in the street, open up that connection, install a transformer, install a sub-meter, close that all up, and then put hardware on top that at best in this country, basically looks like a gas pump. It's large, it's gangly, and it's not really designed. This is interesting because I'm speaking to a different market than I normally do, because you're sort of very lucky that you see a lot of instances of curbside charging in the EU and the UK, where we barely have that here in the United States. So what It's Electric does instead of connecting to the utility is we are the world's first public charging system powered by buildings, meaning we don't have to connect to the utility at all. What we do is we pull our power from spare capacity in adjacent buildings by running a small cable from the building just below the sidewalk to the curb where we erect a public charger. We like to say, think about us as orthoscopic surgery as opposed to open heart. So this allows us to deploy a charger literally in just 2 days, anywhere where there's a building and a curb. So for us, it's a question about using the infrastructure that we already have. What we like to say at It's Electric is that same building density that creates that challenge for every other EV charging provider, because it's impossible to do construction in such densely populated neighborhoods, for us is the solution. Because when we look at a city, every building is actually an electric vehicle charger. We just need to run that power to the curb.
So that's fascinating. So presumably then you have an arrangement then with the building owner.
Correct. And then we revenue share back to them. So we sub-meter, so their bill never goes up.
Got it.
And then by allowing us to, again, tap that spare capacity in their building, keep in mind a level 2 charger is 240 volt, 40 amp, pulls the same power as an electric dryer would that would be running for 8 or 10 hours a day. And then we just revenue share back to that building. So they're seeing 20% top line revenue every month.
That's brilliant. That's brilliant. Everybody's a winner. And you mentioned it takes you 2 days to put those in. So if the public utility were to do that, how long does it take?
Public utility timelines are between 10 and 18 months for an electric vehicle charger.
10 and 18 months, and you're putting them in 2 days.
Correct.
Okay. Yeah. So this is how we're going to solve some of these problems. That's the
our hope.
That's going to get us there. Yeah. That's very cool.
Thank you.
Sebastian, what are you seeing? So there's obviously millions of these assets, ridiculous amounts of data, I would have thought. And what do you do with it all?
Exactly. It's all about, it's not just about having the data, but it's about, as I said in the beginning, having it at the right place and time, and in form and shape, to actually be able to take data-driven decisions from all of this data that you get from these smart chargers or the electricity grid and so on. And when it comes to kind of the leading edge of the innovation that I see in the landscape, in the ecosystem as of today, I think it's really about that kind of unbundling of business models. So becoming much more innovative and not only thinking kind of vertical integration of everything that you do, which is kind of the old school in my opinion, but thinking about interfaces, thinking about partnerships and collaboration and APIs, and how can you share data with others, and how can you create layers and infrastructures that others can use and build on top of. And that is kind of what I think is super exciting now in the space, and it's also a sign kind of that the space is maturing in the form of like a digital infrastructure and digital space. I think we've seen it already when it comes to digital banking, and that is happening all over again now in the energy space as well. So you're right, it's going to need to be able to be interoperable with this exponentially growing amount of distributed assets. So I really believe that the world will be an API first world where we deploy the future of the energy system. And I actually have one visual as well, if we have time. So I can show you a little bit how we think about this at Rebase side. So just need to make sure that I can share my screen here. Okay. So I have a new installation of Zoom. So I think if I just allowed it to share the screen here and use my my screen, but I need to leave the meeting in order to be able to share it. So what about just moving forward with the next question instead?
Yeah, no problem. That's fine. But I've got a question for you though, Sebastian.
Yeah. Go ahead.
Before I let you go on this one, so you talked about APIs. I completely agree with you. I think that data has to be it has to be available, and it has to be available in common formats. So what about common tooling and common approach to data? How do we? So for example, if we got somebody with EV charging, we've got somebody with storage, and you may have somebody installing some generation capacity. Completely different companies, but presumably you've got tooling that would. I mean, how do you share that data between people? How do you even start to think about that?
Exactly. No, that's a super interesting and difficult question. So I think it to a big amount kind of boils down to having common interfaces and standards along which you kind decide to share the data, so that you know that a kilowatt hour is a kilowatt hour is a kilowatt hour, no matter where from the grid it comes. I think that is like a big part of it. And that's on the data side. And then you have the tooling side, which is kind of, in my view, more like, the algorithms, how do you process the data, massage the data, make useful insights out of the data. And I think that there's a lot to do there as well. We see that now in the kind of generative AI space and in the AI space as a whole, that there's a lot of harmonization and kind of standardization also in the tooling space. I'm thinking about interfaces that you might be aware of, like TensorFlow created by Google, or PyTorch by Facebook, that is essentially tools or standards around how to build neural networks, but actually not the whole neural network itself. So it's kind of a standard of a way of doing a certain thing. And I think this is actually likely to kind of develop also in the energy space, that we have more and more standardization across tools that are developed by companies or researchers or independent data scientists that are much more, shareable and modular than we see today. So today we typically have a situation where, a certain company is developing a solution, and then it typically is actually a couple of people in that company that are the kind of the masterminds and have this specific algorithm as the kind of the brainchild. So it's easy to see that becomes a kind of a simple failure mode and a kind of a single point of failure, so to say. If let's say that person just leaves the company, who will maintain the code, who will make sure that it's up and running and doing what we want it to do for the prolonged area of time that we want to run the energy system and our kind of critical infrastructure on. So I definitely see a lot the value and opportunity in having more shareable code that is open source, where we don't have a single point of failure, and we can be much more kind of robust and have a common view on how to do things.
Yeah, it's really interesting. I completely agree, by the way. I guess if we could look forward, 10 years time or some period of time in the future, Tia, I'll come to you. What does it look like in the future? So we've started to solve some of these problems. We've started to see traction in the market. There's adoption at a consumer and at a city level. So people are putting solutions in and changing the way we're doing. What does it look like in the future? How do we move forward? And what does if you crystal ball time, what would it look like in the future?
In the future, I believe that energy in many ways will be a new currency. We talk about V to G, we talk about V to B, we talk about V to X. We have all of this transference of power happening in areas where there's natural disasters here in the United States, where people are using their Ford F-150s to power their homes after a hurricane, after a storm.
Yeah.
So for me, it's about energy and the ability to harness it and move it to the technology that we need it in. Do we need that energy in our vehicle right now? Do we need it to power our refrigerator? Do we need it to power up our generators? This is the way that we're going to try to sort of think about things. It's going to be a lot more fluid. And also there's the opportunity within that energy cycle to make it virtuous, right? With our removal from fossil fuels, and if we're able to harness the power of solar, wind to bring this energy in, and then to transfer that to our building or to our vehicle, it's almost sort of like the way that nature intended, right? We have the technology to do this now. And we're clever enough as a species to be able to kind of like turn the switch on, turn the switch off. So, it's a much more harmonious way of living on this planet than the way that we currently engage with our resources. And that's sort of like that crystal ball that inspires me the most, is to think that we can do this a better way than we've been doing it since the Industrial Revolution. Of course, we didn't have the technology back then to do what we're doing now. Yeah. However, I will point out that the first cars were electric, and then they switched to gas from there. So we took a misstep in that process, and now I think is a chance for us to get back on the right track.
I love that. I completely agree with you. I think we've got to a point, and we've moved forward relatively quickly, I guess, as a species. We've evolved reasonably quickly, but now it's time to do things much smarter, and we can do that. You can see the way technology is developing extraordinarily rapidly. I can see that. I can see the U3 solving problems like that and bringing things together. And it will be very interesting. That virtuous circle, it's very compelling that we can do that, and the technology is there for sure. Konstantin, what do you think? Where are you? What do you see in your crystal ball in the future?
Actually, I love the thoughts of Tia, especially about energy as a new currency. I thought about it a lot before. So, and surely renewables and electric vehicles are unstoppable trends as the climate changes. And it would be fantastic if we would take, if it would take 10 or 15 years, but I think it's a big thing for the next 40 or even 50 years around the globe. And just let's jump to the 2040s and just imagine that 100% of electricity is generated by renewables. Most of the vehicles are electric, if not everyone are, and reliable, green, and stable energy supply everywhere. And the key to this future lies in the balance between consumption, supply, consumer, and generation, and managing all these distributed assets on the local level. And I think it could be possible only via binding a centralized approach and decentralization in the electricity system. And a key element for achieving this future is storing energy on the local level and managing all these distributed assets in the distribution grids. And I believe that Visionary became a gold standard for decentralization of the distributed grids. And yeah, that's our vision, and that's why we've created Visionary.
Yeah, I think you're right. The distribution system and managing it at a much more local level is and we start to see some of this emerging now. Sebastian, you talked a little bit about it in answer to your last question. Anything to add? Crystal ball. Where do you see data and the tooling?
Yeah, I mean, I would bring in one more perspective here. So I fully agree with the previous speakers. But so what kind of we had as the old energy system was this very linear flow of digging up this party trick of digging up fossil energy from the ground, storing it, burning it, making useful work with it, and then emitting it into the atmosphere in a very linear flow. And now we're going to a system which is much more driven by natural forces, solar, wind, hydro, hydrogen, all these things that need to kind of always be in sync and in match. So the balance of tomorrow's system, be it globally or locally on the distribution level, has to be much more dynamic. So when I think about that, I almost think about it as a flock of birds, with all these distributed assets, one bird representing one assets, and then we're all like in sync, in harmony, following each other. And that's kind of the system that we need to build up in order to have that robustness and that resiliency that we need to have from a critical infrastructure as the energy system.
I love that analogy, a flock of birds, a large flock of birds that seemingly moves as one, but there's some communication between them. So you see the thing move as one, but of course they're all individual assets moving, but somehow harmonized. Data's kept in sync, direction. To Constantine, to your point, it's about stabilizing the demand and generation.
Exactly.
That's very interesting. Yeah. At this point, have you got questions between you? Are there anything that any sort of questions? I'd love to throw the floor open, and is there anything thought-provoking around the table? Just jump in.
I mean, I have a question. So to the other founders. So I guess that question would be: so what are the kind of things that you see as roadblockers, or what are the top 1, 2, 3 things that are kind of blocking us as innovators, as founders, from like really advancing with the deployment of these technologies and kind of rolling out that zero carbon energy system?
So blockers, where are the blockers? What are the hurdles and the challenges that we have?
Sure. So coming from my perspective of electric vehicle charging, our blockers are speed. We have our solution that technically allows us to deploy as quickly as I mentioned, which is that 2-day protocol. But cities need to want to have this as an amenity to their citizens. And so that's something that's very much 50-50 split right now, or not even that, I'd say 80-20 split in this country, in the United States. Some cities have their pathway already set. DC is very clear. Los Angeles is very clear. New York just released a request for solutions to help them reach the goal of 10,000 curbside chargers. Just so you have a quick comparison point, London has 6,000, New York has 100, just to kind of give you a sense of where we're at. Other cities are waiting and watching.
Yeah.
They're not moving quickly. They're waiting to see what other people do first. So I think that's always going to be the way, but I think that we truly need to be all in and not wait. if we're going to actually make any of these deadlines that you mentioned at the head of this call, Tim, 2025, 2030, 2035, 2050. The UN SDG goal to cap all GHG by 2025 clearly is not going to happen. So that's supposed to be our that's supposed to be our point of no return, right? So what happens when we don't hit that? I always remark that, we had, of course, the phenomenon of orange skies here in the United States several times over the last 2 years from the result of wildfires. And it's pretty apocalyptic when you walk out of your door at 11 o'clock in the morning and the sky is bright orange and you can't see a single cloud. It's just, it's Blade Runner, right? And then, of course, over the course of a few weeks, it goes away and everyone seems to just forget about it.
We have a short memory, don't we?
We do, until everyone starts to talk about it. So here in the United States, I was speaking with a group of colleagues, and we were saying, I feel much better now. And we came out with the understanding that during the orange skies, obviously it was visually disturbing, but also in terms of respiration, everyone was having a very hard time breathing. Everyone was finding themselves to be a lot more fatigued, going to bed earlier, being very congested, so we're not quite processing what the health implications of climate are. And I think that once that becomes more clear, people will hopefully feel a little bit more of an urgency, because right now it's not palpable, and therefore people are being conveniently forgetful.
So the blocker then is it's legislation, is a little bit of public opinion and push into the legislative machine so as to get things moving. So that's where you see some of the, even if it's not a blocker, it's certainly dragging feet. It's that people aren't moving quickly enough.
Exactly. It's waiting until it's too late.
Yeah. Constantine, blockers. What do you think? Where are you seeing some of the blockers?
I think the main blocker is power grid. Blockers are power grid companies because they are really huge, and it's quite difficult to implement something absolutely new for them to their existing power grids. And the second thing is funding. I mean, less than 1% of venture capital firms invest in energy and hardware companies. And these two main blockers should be more open for something innovation, not only in software things, but also in hardware and something physical. And I think this is two main blockers for company like Visionary. Think so.
Yeah, it's interesting. Yeah, the big utilities, they have done a great job over many years, but they're huge.
Yeah, they're really huge and really slow, and you need to take 6, 8, or even 12 months before you got some get some contracts or something else.
Yeah, and this is why we need innovators and founders such as yourselves. Obviously, it's going to move things. But I think funding, of course, is going to be critical. You can't do it yourselves.
Maybe to add to that as well, and I fully agree with Tia and Konstantin. It's like status quo and kind of the current way of doing things, the current way of working. We're so kind of deep into it, into the hamster wheel of doing it the way that we always did it. So especially, I would say maybe even more so, maybe in the B2B space where we have large companies that are very, I mean, rightfully so, very risk adverse. In order to embark on new technologies or new ways of working. That can of course be a challenge when you're operating in this space. But there are, I mean, a lot also of companies and individuals that are leading the way. So I was just on the call this week together with a municipal utility company here in Sweden, and they announced their new vision for the energy system last week, which is essentially a zero vision on imbalances on the energy grid that they have. So they are really going for zero imbalance on the grid, and that's the distribution grid. And in order to do that, they're kind of, you know, really taking ownership and in-housing, insourcing all their balance operations, and at the same time also contributing to the wider system with balancing services, regulatory power to the system operators, and so on. So they're really taking a huge kind of responsibility and ownership over the situation. And I think that like this, it will be this kind of, you know, four runners that will show the way, and eventually the others will kind of jump to it as well and come to the same conclusions. But we really need that kind of what's called this kind of diffusion of innovation to kind of pass through the whole ecosystem.
Yeah, it needs to be embraced everywhere, doesn't it?
Mm-hmm.
Yeah,
exactly.
Yeah. Any other questions, Konstantin, Tia?
Yeah, actually, I have a question for Tia. What about off-grid cases for your curbside stations? I mean, for example, 1,000 charging stations along the way from London to Madrid or from New York to LA. Have you ever thought about off-grid cases?
Yeah, we really are focused on meeting the day-to-day needs of charging as opposed to long distance travel. You know, it is, even though, you know, this conversation has been focused on level 2, we do need both level 2 and level 3 in this country in order to be able to meet this need and to be able to continue to still function largely business as usual. So for cross country, you know, for, you know, New York to LA, anything that's where we're not in a case of dense urban conditions, you know, that's for fast charging, that's for battery backup charger, that's for solar charging. There's a lot of incredible companies out there addressing that specific need. And we're very clearly staying laser focused on what we're looking to do, which is meet the needs for daily driving in dense urban conditions, especially not just for private drivers, but for rideshare. Don't forget Uber, Lyft, all need to go electric by 2030. Most of these drivers do not live in the city center. They live in the outer regions. You know, a good 20, 30, 40 miles from city centers where there's a complete absence of electric vehicle charging. So helping to, again, bring all communities into electrification, regardless of median income, regardless of prevalence of a driveway or garage. So, you know, we're not interested in that long haul solution, but I'm keenly watching what other people are doing to solve for that.
Got it. Thanks.
Tia, I have a stupid question. Just define level 2 charging for me.
So level 2 is AC. So it's alternating current, 240 volt, 40 amp. You get about 25 miles per hour of charge. You can get your battery full in about 6 to 8 hours, and allows you to get your battery up to 100%. DC fast charging is not alternating current, it's direct current. So it's a much higher power pull. And that's what's known as, quote, fast charging in this country. And that's where you get your battery up to only 80%, because there's a curve that drops in terms of energy transmission. It's, you know, about 5 times more expensive to charge on a fast charger than it is on a level 2 charger. And it takes under an hour.
Okay, yeah, it's a big difference, but also challenges, infrastructure challenges as well. Yeah.
Yeah, but
Okay.
we like to, I mean, like when you come home at night and you go to bed, you plug your phone in, you go to sleep, you wake up, your battery's full. Do the same thing for your car. And then of course, when you need it, you would need to kind of have that fast charge when you're going from state to state. But for your, an average EV battery is around 200 plus miles. And the average city driver puts no more than 40 miles on their vehicle across any given week. So I like to say, like right now, when we're dealing with fossil fuels, I don't fill up my gas tank, drive to the dentist, and then go back to the gas station, then top it back up.
Top it up a little bit, yeah.
Yeah, like that's not how we function. And so there's this sort of weird transition that people are getting anxiety from the way that this is being reported, that you have to constantly be charging. You don't.
Yeah.
You run your gas down. People like love to like bring that meter down to almost E.
Yeah.
And then we bring it back up. So it's the same thing. And I think also, sorry, just a fun little observation that I have. I would love for vehicle manufacturers to change their interfaces for electric vehicles. Right now, when you drive an EV, it says 19% left, 18% left, and it psychs you out, as opposed to kind of just watching your full to empty meter go lower.
Like you would do in a traditional petrol car. Yeah.
It sort of creates this sort of anxiety around scarcity. So I think that's an interesting thing that should be evaluated in general when we look at the way interface and the way we engage with a new line of vehicles.
I think that's interesting. I think the psychology of how we deal with that range anxiety. I remember when I first drove an electric car, I instantly had range anxiety, and then of course the electronics take over and you just start to trust it and it works. But you think, my goodness, how far am I going to get? I've noticed we're almost out of time, folks. So I think I'm going to wrap it up there, if that's okay with you. It's been a really, really interesting discussion. Nearly an hour has flown by. I think we should do it again. That was very interesting. I think we just skimmed the surface. So I think what remains, is there's obviously huge challenges. We've got, to get to a net zero economy. But I think that what I see and you see is innovation and entrepreneurship is happening. It's there, and I think the vision and energy of you three gives me great hope that we've got a very exciting future. I think we've got an awful lot of hard work to do, a lot of changes in behaviour, but I think I think we'll get there. So I think I think that we'll wrap it up there. Thanks very much. I think if anybody watching is new to energy and they're thinking about some training, please do reach out to me. Can also reach out to anybody on the call here if you want some more information or you've got any more questions. So finally, many thanks to the three of you, to Tia Gordon, co-founder of It's Electric, Konstantin Fedoseev, co-founder of Visionary, and Sebastian Haglund, co-founder of Rebase.Energy. Thank you all very, very much. It's been really interesting. I was Tim Rogers, and from Energy Wise, thanks very much all for watching and listening. Goodbye.
Thank you.
Bye-bye.
Bye.